Welcome to Study Loop.
For this problem on the topic of waves and sound, we are told that an explosion occurs at the end of a pier. Now the sound reaches the other end of the pier by traveling through three different media. Firstly air, then fresh water, and as well as a metal handrail. We're given the speeds of sound in each medium, and we also told the distance that the sound travels in each, which is the same, and we want to know through which medium the sound arrives first, second, and third. And then after the first sound arrives, we want to calculate how much later the second and third sounds arrive. Now, in order to determine the order of arrival of the three waves, we need to know the speeds of each wave. And we know the speed of sound in air, or the speed of the wave in air, is 343 meters per second. The speed that the wave travels through water is 1,482 meters per second. And the speed that the wave travels through the metal handrail, Vm, is 5,040 meters per second. Now, since the three waves travel the same distance, the order of arrival is as follows. So the metal wave will arrive first since it is traveling at the fastest speed. The water wave is slower than the metal wave but faster than the wave in air, and hence it will reach second. And lastly, the wave traveling through air is traveling the slowest, and so it will arrive third. So that's the order at which the sound waves will reach the end of the pier. Now, for part B, we want to know the time delay between the second and third sounds. Now we first need to calculate the length of time each wave takes to travel 125 meters. So the time through metal is equal to the distance through metal, 125 meters, divided by the speed, which is 5,040 meters per second. So the time through metal is 0.025 seconds. The time the water wave takes to reach the observer at the end of the pier is the distance 125 meters over the speed of sound in water 1,482 meters per second. This gives us the time of 0.084 seconds. And finally, the time that the sound wave through air takes is again 125 meters divided by 343 meters per second. And that's a time of 0.364 seconds. And so therefore we can calculate the time delays. So the time delays between the first and second waves is equal to Tw minus Tm. And so this is 0.084 seconds minus the time it takes for the wave through metal to arrive, 0.025 seconds, which gives the initial time delay between the water wave and the metal wave to be 0.059 seconds. Now we need to calculate the delay between the wave in air and the wave in metal. So delta T 13 is equal to the time that the wave takes to come through air minus the time to metal, which is 0.364 seconds minus 0.025 seconds. And so calculating, we get this time delay to be 0.339 seconds.